Support handout number 15. Problem number 1, we want to simplify each expression. Most of these are pretty quick. When I look at part A, what I see there is a sine over cosine. Sine over cosine is just tangent x by our quotient identity. So I'll still have the 4, and then sine over cosine becomes tangent for tangent x. Letter B, the 6's can certainly divide out, and then I have cosine over sine. That's another quotient identity. That's equal to cotangent x. Letter C, I know has something to do with the Pythagorean identity. Looks like all I would have to do is move this sine squared over to the other side, and then it would say 1 minus sine squared x equals cosine squared x. And so that would be the answer here. Letter D requires a bit of a trick. It's also related to the Pythagorean identity. What I should do first, though, is factor out that 4 that's common to both terms. And then what I have there in parentheses, the 1 minus cosine squared x, that is again related to the Pythagorean identity. This time I would be moving the cosine squared x to the other side. It would say 1 minus cosine squared x is equal to sine squared x. And so I can make that substitution then. I don't even need the parentheses. And my final answer here is 4 sine squared x. Letter E is very simple. Just reciprocate that secant x up to the top, and it becomes cosine x, 3 cosine x. Problem number 2, we're being asked to work out these trig expressions by hand. This is just going to be a matter of drawing some quick pictures. It looks like in each case we're multiplying a couple trig values together. The first one, maybe you've done this enough to just know by now that sine of 30 degrees is 1/2 and sine of 60 degrees is root 3 over 2. Those come up a lot, which means the final answer here is square root of 3 over 4 when I multiply across. Obviously, if needed, you could always draw the quick picture. We've done it many times. It'd be the 30, 60, 90 triangle with the 1, the root 3, and the 2. Actually, from this picture, you could get both of these values. I can see sine 30 as 1/2, opposite over hypotenuse. And since this is a 60, if I did opposite root 3 from the 60 over hypotenuse 2, I get root 3 over 2. Final answer, root 3 over 4. Okay, letter B, pi over 2 is quadrantal. That's 90 degrees. That's a unit circle calculation. That's right up here. This is the point 0, 1. Sine gives me the B coordinate, so that would be 1. Cosine pi over 4, that would be from a 45, 45, 90 triangle. And so I can label that as we often do. Cosine pi over 4 is 1 over root 2, although as we've done many times, that's going to rationalize to root 2 over 2. And obviously multiplying by 1 is pretty simple. The final answer here would just be root 2 over 2. Part C, let's see, both of those are quadrantal. 270 degrees is down here at the point 0, -1. The sine is the B, so this would be -1. And then 180 is right here at the point -1, 0. Cosine is the A, which is also -1. So this is -1 times -1, +1 is the answer. Part D goes back to pi over 6. That's 30 degrees. I ought to be able to get that from this picture here. Let's see, the tangent of 30 degrees, that's opposite over adjacent. And then cosine of 30 degrees is adjacent over hypotenuse. And this works out pretty nicely. The root 3's divide out for a final answer of 1/2. Letter E, tangent of 60 degrees. I can get that off of this picture too, as long as I focus in on the 60-degree angle. Let's see, tangent is opposite over adjacent. For the 60-degree angle, that would be root 3 over 1. And then sine of 0, 0 is quadrantal. That's the final spot over here on the unit circle. This is the point 1, 0. Sine is the B. Well, this one works out pretty easy. Anything times 0 is just 0. And then the last one has 3 items to multiply together. They're all 45 degrees. We have that picture right here. Sine pi over 4, opposite over hypotenuse, 1 over root 2. Cosine pi over 4, we did that one already. That was 1 over root 2. Tangent pi over 4, let's see, that's opposite over adjacent. When I multiply across, 1 times 1 times 1 is 1, and on the bottom, root 2 times root 2 makes 2, times 1 is still 2, and so the answer here comes out to be 1/2. And then number 3 is just a reminder about the relationship between the regular trig functions and the inverse trig functions. So I'm being asked here, find the sine ratio for the angle whose sine ratio is 2/3. Well, obviously then the answer must be 2/3. I mean, you could draw yourself a picture if you wanted to. It would have to be in the first quadrant. Sine inverse has a positive ratio there, so I know it'll be in the first quadrant. And I could put 2 over 3 here, opposite over hypotenuse. Here's the angle in question. Now, I have no idea what this angle is. This is not a special triangle. I'm just being asked to find the sine ratio for that angle, which is obviously 2/3. It's the same thing in part B. 3x is a ratio. You can think of it as 3x over 1. I'm being asked, find the cosine ratio for the angle whose cosine ratio is 3x. Well, that's going to be just 3x. Again, if you wanted to draw it out, we'll assume x is positive. You could mark 3x over 1. Here's the angle. No idea what it is, but I don't care. I just want the cosine ratio, which is 3x over 1, or 3x. As long as this is a valid ratio in here, this relationship we've noticed will always work.